or we don't necessarily need to be in video.
Yeah, yeah. Okay. So I just informed you before I started the streaming. Okay. So now you will not be in on YouTube. So this was the YouTube link for today's session. So I just pasted it in the chat, and I will also paste this in the calendar also. So you can come back and revisit our session later. Okay. One final thing I have to do. Let me share my screen, and we'll start discussing week two content, week one and two. Okay. Is my screen visible?
Yes,
Yes,
sir.
sir. Yes, sir.
Yes. So
Yes, sir.
yeah. So these are the contents which I'm going to discuss in today's session with examples, problems, where if we try to solve these problems, you will get an idea how to solve the problems of mock as well as mock. How many of you looked at mock? Mock has been released, right? Last Friday, yesterday.
For 3 and 4. For 1
Oh,
and 2. Week 1 and 2.
hmm. One and two. We released mock quiz, right? No.
So mock
Yes,
for
sir.
quiz one was released
Ah,
yesterday.
mock for quiz one was released yesterday. Please take a look at it. Okay. So if you try solving mock for quiz one, because it resembles your quiz one paper. Okay. So in some sense. So today also we will try to solve the same kind of problems, and you will get good hands-on experience to attempt quiz one. And one final note is, if you divert me with some other topics, I might go on discussing on that unnecessary topics, and it might waste your time and my time too. Okay, and all of our time. So let's stick to quiz one boundaries, within the quiz one boundaries, and let's not deviate to some other topic and discuss. It may be from stats too, but if I'm not discussing that, it is not that much important for your quiz. Is this clear?
Yes, sir.
Yes, sir.
Okay. Okay, let's start then. So today we will start again looking from what is this joint probability mass function. In short, this is called PMF. Okay, and then we will see what is this marginal PMF, conditional PMF, and problems involving this joint marginal and conditional, and what is the equation that connects joint marginal PMF, marginal conditional. We will see, and then we will move to independent random variables. Sorry, independent random variables. So when do we call two random variables independent to each other, and what kind of problems can arise uh, in your assignments or maybe in the quiz also, that we will see. And then we will move to independent identically distributed random variables. In short, it is called as IIDs. So the first I indicates independence. The second I indicates identically distributed. D represents the distribution. Okay, we will see that, and finally we will end and maybe we spend most of our time, we try to spend most of our time on looking at function of random variables. So in particular, okay, let me state it here itself. In particular, in functions of random variables, I want to focus on four important functions. Maybe I will, from now on I will call this as z1, which is sum of random variables, z2, which is as the product of random variables, z3 is max of x comma y, and the final one z4 is min of x comma y. Okay, so in particular we will try to solve problems on these four functions of random variable, function of random. Okay, so So I will quickly give you the definitions also, just to make everyone on the same page, just to bring everyone on the same page. And I will also take examples followed. So let's start with joint PMF. So we all know that joint PMF is basically looking at the probabilities of occurrence of two random variables jointly, which is defined as if I have any two random variables x and y, and still we are in week 1 and week 2. So x and y are discrete. So if I didn't mention this also in this particular session, let's treat every random variable which I am going to discuss are discrete. Okay, so let's suppose say x and y are discrete random variables defined in some probability space. So since they are random variables, they have ranges. So let's say x has range tx, y has range ty. Then joint PMF is nothing but, the notation of joint PMF is like this. This is nothing but the probability that x takes value x and y takes value small y. So this is also a function that takes two inputs, small x, small y, and some value between 0 to 1 is the output, which is the probability. So in representation with respect to function, we will represent it like this. So fxy is a function which goes from the range values of x cross the range values of y. So cross is the cross product to 0 1. Okay, so it takes a tuple or pair x comma y and maps it to some number between 0 to 1, which is the probability. And yeah, where the small x comes from tx and the small y comes from the range of the random variable y. Okay, so I think this everyone knows. And similarly, this has two properties. Okay, let me discuss those two properties. So the first property is, when you add up all, when you consider the summation, double summation, x belongs to tx and y belongs to ty. If I consider this joint PMF value for each x and y coming from tx, ty, this will be equal to 1. Okay, and whatever the value that this function takes will always stay between 0 to. So these are the two properties of joint PMF values, probability mass function values. And this is mathematical expressions. This can also be represented visually via tables. So we call them PMF tables. So I'm getting an echo slightly. Can I request everyone to be on, please be on mute unless you have any doubt. Thanks. So yeah, so visually we can look at the joint PMFs till two random variable case. So at least we call them as PMF tables. Joint PMF tables. Okay, so how does it look? It looks somewhat like this. Right, so x and y. So this is just to represent whether you are considering your row values of as the range of y's or x's. So if I represent it like this, x takes, so whatever the values that x takes will come as columns, 0, 1, 2 or whatever, and whatever y takes will come as rows, y and x. And do not confuse whenever if we have given like this, we can also give like this. So that represents the range of y values are 0, 1, 2 and x can be 0, 1 or anything. So always look for this particular entry, how x and y's are placed, whether x is below or x is above. That will give you the range of values of x and y. Okay, and there will be some probability values 0 0.1, 0 0.3, 0.2, or some can be zeros simply, and 0.3 and 0.1. So it can be any value between 0 to 1. So the same properties hold, and all these entries are the probabilities. So this entry represents the probability that x takes value 0 and y takes value 2. So why? Because I have taken x and y like this. So it says that y takes value 0, 1, 2, x takes value 0, 1. So this particular entry represents probability that x takes 0, so that particular row and the corresponding column. So this is 0th row and second column, third column.
So, sir, just on doubt, in this case, the small x will be 0 and 1. Similarly, small y will be 0, 1, 2.
Right. So here small x can be 0 or small x can be 1, because your tx will be 0, 1. Okay. Similarly, y can be 0 or y can be 1 or y can be 2, because since ty, the range of values of the random variable y is 0, 1, 2. So y, small y can come from any one of this 0, 1, 2. Okay, so this probability that x is equals to 0 and y is equals to 2 is nothing but fxy of 0, comma 2, or this can be written fyx 2, comma 0. Again, so whichever the random variable you are writing first, that particular corresponding value should go in here as a first entry. Okay, so never confuse with xy's. Okay, so this is about the joint PMF. For example, if I have given, for example, let me take a new page. Let me give this example explicitly. Okay, so here I have given y, here I have given x. So y takes values 1 and 2, x takes values 0, 1, 2. Okay, and the values are 1 by 6, 1 by 4, 1 by 6, 1 by 8, and 1 by 8, 1 by 6. So my first question is this a valid joint PMF table?
Yes.
Oh.
2 by 12.
So how do you check whether a given joint any given table is a joint PMF table? You
By
just have to
By
adding all.
use
sum of all elements is 1.
sum of
Yes.
all elements is 1, and other thing is whatever the
They are
entries
greater than
All
0.
the inputs should be
greater
greater
than
than
0
0 and less
and
than
less
1.
than 1. Okay, so these two properties are always important, which helps you to check whether a given table is joint PMF or not. Okay, so property 1 and property 2. Okay, good. This is yes. Yes. So once it is yes, there are many questions that can be asked on this particular.
But a value can be 0, right? It should be greater
Can be
than
0.
0, or it can be 0.
So whatever the value, entry value should be in between 0 and 1. So it can take 1 also, but it's very unlikely to take 1. If it takes 1, then all other entries should be 0.
Correct. Thank you.
Okay. So the next question is, what is the probability that x takes value 2 and y takes value 1?
One by eight.
1 by 8.
1 by 8. Yes, sir.
1 by 8. So maybe the other question might be like, what is the probability that y takes 1 and x takes 0?
1 by 6.
1 by 6.
1 by 6. So always look out if it is if a joint PMF table is given to you, and if you are asking just the joint PMF value, then you just go to the corresponding entry and just pick the value from there. Okay. So this is about joint. Now, if I wanted to talk about marginal, can I build? So maybe I will write it. Let's move to marginal PMF. Again, let me define what marginal PMF is. So marginal PMFs are, in some sense, marginal PMFs are just the probability mass function of individual random variables. So we have x and y together, but what is the individual probability mass function of x and what is the individual probability mass function of y? So how do we compute? If a joint PMF is given to you, again the definition will be like this: x and y are, again I am not mentioning discrete here, you just consider x and y are discrete. This. So this represents discrete random variables, and also this time we have the joint probability mass function of x and y. So this is joint PMF. So we are interested in computing marginal PMF. Marginal PMF, they are denoted as either fx of x if the random variable is x, or fy of y if the random variable is y. So here we have jointly distributed random variables x and y, and I wanted their marginal probability mass function, or in some sense I wanted the PMF of x separately and y separately. So how will I compute from the joint PMF table is, I will just sum over all the values that comes from the range of unwanted random variable. So if I want the marginal PMF of x, so what I will do is I will take each and every value that y takes, the other random variable takes, and I will sum over all the possible joint PMF values. Okay. So here y will change, x will stay constant. So this x small x, for each and every value, these two will stay constant, and these values, so it will sum over all the y's. So that means this will vary. So once it will be 0, 1, 2, if the range of y is 0, 1, 2, 3, 4. So then in the start it will take 0, and then it will sum to 1, 2, 3, 4, and so on. And similarly, now you can guess, if I wanted for y, so these are in some sense individual PMFs or the separate PMFs. Okay. So if I wanted the individual PMF of y, I will take all the possible values that x takes. This should be ty. And I will sum over all the probability mass, joint probability mass function values. Xy of x comma y. Now this time y stays constant, x will vary. x varies. So in some sense, marginal PMFs are just if you have the joint PMF table given to you, you can compute the marginals just by adding the rows and columns. So that's what this expression also tells us. Okay. So let's go back to our example. Let me take this example. So if I have the same joint PMF table like this, how can I compute the marginals? So this time the question is compute. Okay, maybe we'll start like find fx of 1. What will be fx of
1 by
7 by
6 plus
24.
1 by 8.
1 by 6
by
plus 1 by 8? So
7
what
by
we have
24.
to do is we wanted, so x takes value 1 in this particular row. So you wanted x should take value 1. So since you wanted this, you just go back to the definition. You wanted x, so that means you have to sum over all the values that y takes, and you sum it over fxy of, here small x is 1, so that will stay constant, and y. So what are the set of values that y takes? Either y takes 1 or y takes 2. So first time small y is 1. So if small y is 1, then the value is fxy of 1 comma 1, and that will add up to fxy of 1 comma 2. So next time small y will take value 2, because y only takes 2 values. So if I had taken some 4 or 5 values, so this summation will go till 5, fxy of 1 comma 5. Okay.
Sir,
So in our problem, yeah.
one doubt. So in the previous example, we talked about the entire PMF, and we said two rules. One is the probability of individual should be less than 1, greater than 0. I mean,
Each
equal
entry
to
should be less than 1 and
Yeah.
greater.
But when we talked about the second rule, that all the sum of all probabilities equal to 1, that does not hold good for the marginal.
It
Correct?
will hold, no?
Okay, but we are getting only 1 by 6 plus 1 by 8.
So that is only for one value, right? So this is only the marginal PMF value for x is equals to 1.
Okay.
So x will also take 0, x will also take 2, right?
Oh, okay. Understood.
So that is going to be my next questions.
Okay.
So this value is, you can compute fxy of 1 comma 1. So given a joint PMF table, how to get this value. So you just go to the first the row which represents 1 and the column which represents 1. So this is the row that represents 1, and this is the column that represents 1. So 1 by 6 will be the value. Similarly, 1 by 8 will be the value. So if you add these two, you will get what will we get? 7 by 24. Right.
Yes.
We will get 7 by 24. Okay. So this is okay. So this is fx of 1. So if I had asked my next question to be fy of 2, what should be fy of 2?
Summation of x in the
13 by 24.
1 by 4 plus 1 by 8 plus 1 by 6.
Right. Good. So what you have to do is, I wanted the individual, previous question, I wanted the individual PMF value at 1. So you just go to x rows, what x is representing, x values are in rows, and you just go to the corresponding row. So if you had asked for fx of 1, you just go to that where this x is equals to 1 is representing, which row. So this row. So once you are in that row, you just add all the values in that particular row. Similarly, if I ask for fy of 2, so you just see whether y values are in columns or rows. So here y values are given in columns, and you just go to the column that has value 2. So which is that column? This is the column. So you go to that column and you just pick that column, and whatever the value is there in that particular column, you just add every value. 1 by 4 plus 1 by 8 plus 1 by 6. So this will give us 7 by 24 plus 1 by 6 plus 4, 13.
11 by 24, I guess. 13 by 24. Okay.
7. Is it 11 by 24?
No. 13 by 24.
13 by 24, right?
Yeah.
Okay. So it will be 13 by 24. So what we got is, we will just extend the table of joint PMF and construct a bigger table that will actually capture both joint PMF as well as the marginal PMF. So we'll extend it like this. So you will add a column and you will add a row to your joint PMF table. And now I want to know what to be written here. What to be written?
FX.
Yeah, that is Fy.
Okay, maybe I will give you points. This is point A. This is point B.
Point A will be Fy.
Point A will be Fy.
Fy.
No, point A will be
FX.
Yeah, point A will be
Point B
Fx.
will be Fy.
Point A will be Fx. Point B will be Fy.
Right.
Yes, sir.
Yeah.
So if you truly confuse, that is correct. So this will be Fx of x and this will be Fy of y. But if you are getting confused, you just see what will happen if you add up row. What will you get? This is nothing but Fx of 1. If you add this first row, you will get Fx of 0. And if you add the last row, you will get Fx of 2. So this is actually capturing the individual probabilities of x. So therefore, this will be Fx of x. Okay. And can some of you give me the entries for all the entries? So this is very simple. 1 by 6 plus 1 by 4 is just 10 by 24, which is 5 by 12.
The first column is 11 by 24.
And the second one is 7 by 24.
So this will be, okay. The first column, if you add up the first column, this will be 1 by 6 plus 1 by 6, which
11
is 1
by
by
24.
3. 1 by 3 plus 1 by 8 is 11 by 24.
Yeah.
Correct. So once it is 11 by 24, do I have to add all these three, or is there any good way you can?
You could just subtract it by
1
1.
minus 11 by 24, which
Right.
means 13 by 20.
Good. Because y can only take two values. If you know that probability that y takes value 1 with probability 11 by 24, then it will obviously take obviously take value 2 with probability 1 minus 11 by 24, which will be 13 by 24. Even the computation also shows the same thing. So if you add up 1 by 4, 1 by 8, 1 by 6, it will add up to 13 by 24. And 1 by 6 plus 1 by 8, we just computed, it is 7 by 24. Again, you can get this value in two ways. Either you subtract 1, either you subtract the sum of these two from 1, or you simply add 1 by 8 plus 1 by 6. If you add it again, it will give you the same value, 7 by 24. Now, to cross check, you can do one thing. So you got these values, but to cross check, what should you do is, you just add up all these three. Just check whether you are getting the value 1 or 2. And add these two and you should get 1. Okay. If you had computed only using the joint PMF and got the marginals, then add up the marginal values and check whether it is happening to be 1 or 2. If you had done these kind of tricks, 1 minus of this or something like this, the checking is, once you get this value, then go back to the joint PMF table and add up these values and cross check whether you are getting 13 by 24 or not. Okay. So this is how you can cross check your values, whatever you got. Okay. So we are okay.
Sir,
Yeah.
I have a doubt. Sir, in the PMF table, and the two conditions you tell, first is like summation of all the entries must be 1, and the second condition, all the probabilities must be between 0 and 1. So second condition, in the second condition, the second line, that it should be less than 1, that is already taken care by first condition. Na? So why to add that?
Why need to?
Why we need to add that less than 1?
Oh, why we need to add that less than 1?
Yes, sir.
Okay, it's just a property to mention that each and every entry that comes in, see, the entry should not be like this. Something like, if I had given a table 0 1 0 1, so some entry is 2 and some other is -1 and half
No,
and half.
this greater than equal to 0 is okay, but why less than 1?
That is why, see, greater than equal to 0. Acha, you said greater than or equal to
It should
0.
be there, but less than 1, that is already taken care by the summation of all
Taken
the
care by
entries.
summation is what you say. Okay.
Yes, sir.
Okay.
No.
Then
Generally, probability is always between 0 and 1, right? So
0 and 1. Yeah.
so that is what it is.
No, his question is, if you said the first property, if you add up all the values, then you are saying that it should be equal to 1.
No,
And
that
what
is
is
correct.
it now?
For that, your explanation is correct, right? Now, in this example, if you add, it will be 1. So this is not a complete condition. You have to read both conditions, right? It has to be less than 1 and add everything should be 1.
Yeah, I agree. But the thing is, if I had given only each and every entry greater than or equals to 0, and then said if you sum up all the entries, that should be equal to 1, that will also be sufficient.
Yes, sir, that is my question.
That is also sufficient, but saying it should be less than 1 doesn't lose anything, right?
Yes, sir.
Okay.
And since we are talking only about
probabilities,
is between 0 and 1.
Yes, it is good to mention between 0 and 1. Okay, so we are done with joint, marginal, and the next brother is conditional. So conditional PMF, in some sense, this is like, so I will fix one random variable. So I will condition on one random variable, and I want to look at the probabilities of the other random variable. So how will the probabilities change? So that is what, in some sense, this conditional PMF captures. So given, this is the definition, given some x takes some value small x. Okay, so this is given to us. So we have drawn a sample, or maybe you performed an experiment and you just saw the outcome of the random variable also, of one random variable. So it took small x. Now, once it has taken this value, how are the probabilities of the other random variable vary? We say, given this, then the conditional probabilities of y is represented. So this is the conditional probabilities of y.
Raghuram, your mic is on, I guess.
Okay. Thanks. Raghuram, can you mute, please?
Yeah, sure.
Yeah. So conditional probabilities of y means, so what is the probability that y takes some value y conditioned on x has already taken value x. So this is what conditional PMF is. And how do we compute this? Given a joint PMF to you. So given joint, just now we saw, we can compute marginals also. So once you have joint and marginals with you, so this conditional is in some sense joint by marginal. So it is again in some sense you can see. So given that x is equals to small x, so now you know what is the probability that x takes small x, right? So you know this. It might be some p, small p, or maybe some small r. Okay. So you know with what probability this will occur. Now you have known that this has occurred. So you simply, what you have to do is this R becomes 1. So you can also do like this in conditional, if you have to compute the conditional PMFs, you can do like this. So if the small r becomes 1, you look at the joint value of this probability that y is equals to small y and x is equals to small x. So you know what is the probability of this, because you have joined with you. So it can be R1. Okay, in normal space, without conditioning or doing anything, you can compute the probability that x is equals to x, which can be some r, and you can also compute the joint probability mass function value of y is equals to small y and x is equals to small x. It could be some yes, small s. Okay, so now you said x is equals to x has occurred. Now it's occurred. So since it had occurred, the probability of that occurring is 1. Previously it was r, now it was 1. Now if r is 1, what will be s? So that's the question. And we all know this cross multiplication stuff and all. So this question mark, if you want to find the question mark, this will be simply s into 1 divided by r. So from there this arises, how this joint PMF divided by marginal. So this s is nothing but the joint PMF value, this r is nothing but the marginal PMF value. So this we didn't discuss earlier, but if you are confused with conditional PMF and if you are not getting sense of what conditional PMF is exactly is, this is what it means. Okay. So let's
sir, sorry sir, can you explain this once again?
I seriously don't want to. Can you just go back and see?
Okay, sir.
Because it's just to give intuition, and I felt intuitions are not this is not the right place to give intuitions.
Okay, sir.
Okay. Yeah.
Sir, I meant to ask one question from the previous topic, if I may, please.
Okay.
I will not digress too much. Is there a way, or is it logical enough to derive at the individual PMF values given only the marginals? Is there a way?
No.
Or no? Right?
I got your question. So given marginals, can you go back to joint human, I suppose?
Yes. Yeah. Correct.
So that's not possible, and that's a good question to be addressed now. See, the thing is, given joint, we can go and compute marginal PMF. Once you have joint and marginal, you can compute the condition.
Okay.
So this can happen. So you can compute, you can go for it. But the problem is when given only the marginals, then the sad part is we can't compute joint or maybe the condition.
Because there might be more than one.
So
Okay.
the only challenge is you can look at from the table perspective itself, from the table perspective. So you know the sum of the rows and sum of the columns. Having the sum, you can't split that sum into 3 different parts or 2 different parts.
Yeah, understood. Okay.
Understood, right?
Thank you, sir. Thank you. Yeah.
Okay.
Sir, but in case of independent, we can make na?
In case of independent, but I didn't discuss the independent as of now, right? So
yes, sir.
After I discuss independence, I will come back to this and then we can. Okay. So this is joint PMF. This is conditional PMF. Conditional PMF is somehow connected to joint and marginal. So from this, we have our very good friend, or the very important expression, which is the joint PMF is the product of conditional times marginal or marginal times conditional. So in notations wise, this is how we represent. So fxy of x comma y. So you can compute the joint. Given marginal and conditional also, you can compute joint. Just you have to do the product of marginal and conditional. If you know the marginal fx of x, and since you know the marginals, you can condition on x and look at the probabilities of y. So this is the conditional PMF representation I haven't given. So the denotion of conditional PMF is somewhat like this. So y given x is equals to x, the whole thing will come in the subscript, and then there will be small y. So this is nothing but the probability that y takes value y, given that this is the given that or condition that. You should read it like that, given that x takes value small x. Okay, so yeah. And you might ask me why only condition on x. I can also write it in terms of y. So that is also valid. So you can write it as product of marginal of y times. Now you condition on y and look at the probabilities of x. So the conditional PMF of x given y is equals to small y of x. So both are valid. So we have to use it appropriately based on the question. So this is very important, and this will help us to solve many problems. Let us take the problem now and try to solve. Okay. So I wanted to add one more extra condition on the next problem. I'm not giving you the joint table directly. Rather, I will give you the function, as a function, joint PMF as a function. So how, let's see how will that look. So now this will be considered as example 2. Okay, so the question is, so this is the joint PMF function. So fxy of x comma y is given to be defined as 1 by 24 x times x plus y, and where x is from 1 comma 2 and y takes values 0, 1, 2 and 0 otherwise. Okay, so is the expression clear to everyone? So whatever I have written,
Yes, sir.
this is the joint PMF. So joint probability mass function. So a function is given to you like this. So fxy going from x comma y to some value between 0 to 1. Okay, so this is given to you. The first question is compute the joint PMF table. So how does my joint PMF table look? How many rows will it have? How many columns will it have?
It will have 2 rows where x will be mapped, 3 columns, y will be y values.
Okay, so try taking like this. So take x this side and y this side.
2 columns, 3 rows.
Good. 2 columns, 3 rows. Okay, so let us try to solve this.
Can we take in another way also, right?
You can take it in another way also.
Okay.
And that will be like 2 rows, 3 columns.
3 columns, yeah.
So since I wanted to give some hands-on experience on how this xy can interchange between each other, that is why I'm taking yx1s and xy1s. Okay. So let me draw the table. So the steps for solving these kind of problems is look out for the range first of all. Then only you will know how many rows and how many columns you have to have in your joint PMF table. So how do I look at the range? Just go back to the function and see this part. This part will tell you the range of each and every random variable. So since we have only two random variables, the random variable x takes values 1 and 2, random variable y takes values 0, 1, 2.
Yeah.
Okay. So this is how it will look like. If I take x on this side and y on this side. Now my entries will be x0, not this, x0, sorry, x1 and 2, y0, 1, 2. So now we have added these things, but we are yet to add these entries.
Yeah.
Now for that, what we have to do, we just have to go back to the expression and start substituting each and every values for x and y's. So this is for the first entry. You can easily see the first entry is fxy of 1, 0. So that should be the first entry, right? So if I want fxy of 1, 0, I know that fxy of x, y. So you have to substitute, in place of small x, you have to substitute 1. In place of small y, you have to substitute 0. So if you substitute, you will get the first entry value. So fxy of 1, 0 is nothing but, on the right side is 1 by 24 times, in place of small x, you should take 1. In place of small y, you should take 0. That's it. So you can compute. This will be 1 by 24. Correct? So once it is 1 by 24, the first entry is 1 by 24. Similarly, if I wanted to compute this entry, what will be this entry? This is fxy of 2, 1.
1 by 4.
So 2,
1 by
1.
1 by 12. 1 by 12.
1 by 12. Okay, let's see. So what you have to do is, right side you have to take the expression
1 by 8.
in place of 2, in place of x, you have to
6
take
by
2.
24, right?
1 by 4 it should come.
1 by 4.
Right. In place of small x, you have to take 2. In place of small y, you have to take 1. So in place of small x, I have taken 2. 2 plus 1. So this will be 1 by 24 times 2 times 3. So 6 by 24, which is 1 by 4. Okay, very good. So this is 1 by 4. So similarly, what could be the other entry values? So I will just give 1 or 2 minutes, not more than that. So I want everyone to take the values and give me each and every entry value.
Sir, fxy 20 will be 1 minus 1 by 24. That will give us.
This will be
23 by 24.
4 by 24, sir.
Okay, what should be? I got 3 values. One is 1
So
by
1 by
24, 3 by 24, 4 by
1 by 8.
24.
No. 4
No.
by 24.
1 by 6.
So 1 by 6.
I
1
got
by
1
6
by
or
1
4
by
by
6.
24. Yes,
Sir,
1
आपकी
by
slide
6.
भर जाएगी.
1 by 6, sir.
Okay, so it should be 1 by 6.
Yeah.
So again, you just put x is equals to 2, y is equals to 0. When you put x is equals to 2 and y is equals to 0, you will get 2 times 2 plus 0, which is 4 by 24, which is therefore it will be 1 by 6. Okay. So what will be 1 comma 1?
1 by
1 by
12.
12.
1 by 12.
Yes.
1 by 12.
1 by 12.
Okay. What will be 1 comma 2?
3 by 8. 1 by 8.
1 by 8.
1 by 8.
3 by 24, which will be 1 by 8. And what will be 2 comma 2?
1 by 2. 1 by 3.
1 by 2.
1 by 3.
1 by 3.
Okay.
1 by 3, sir.
So you should never see, this is what we say in general. So you will solve the most difficult problem, and finally what happens is when you want to do 1 by 4 plus 1 by 2, you will end up entering 1 by 6 as the answer. Okay. So do not do this. Maybe we, in some layman terms, we call it as silly mistakes. So never do like this. 1 by 4 plus 1 by 2 is equals to 1 by 6. See, your whatever you did till now will ruin.
The
And
best will
reward
be
you. Huh?
we do not reduce it to
1 by 3.
1 by 24. We keep it only 24 in denominator. Then we can add and check as well.
So do always cross check your answers if you have time. If you are running out of time, then we can't do anything. God should help us. Okay, what should be the last value?
1 by 3.
1 by 3.
1 by 3.
1
So
by
if you
3.
do the computation, you will get 8 by 24, which will be 1 by 3. Okay, very good. Now that we have computed our joint PMF table, let me ask you interesting questions now. What will be the value of this? Let me start
P
with
of x of equal to 1 by
24.
1 by 6 plus 1 by 4 plus 1 by 3.
right. So the final value, shall I compute or
18 by
3 by 4.
8.
No, sir,
8 by
just
12.
move.
8 by 12 or
Sir, 15 by 24. 3 by 4.
3 by 4.
3 by 4?
3 by 4.
Is
Yeah.
this 3 by 4? Yes.
Yes, sir.
Yes.
Okay. Now comes a slightly trickier part. What is this value? The conditional PMF. So
P of y equal to 1, 2, 1. 1 by 4 by
1 by
1 by
3.
3 answer.
1 by 3.
So I have to compute this thing.
X2.
Sir, 1 by 4 by 3 by 4.
Correct. So this I have to compute, but the thing is we already have some value as no need to compute one value, which is probability that x is equals to 2, which we have done in the earlier question. So no need of doing the same thing twice or thrice. So if you have given some comprehension kind of question, make use of the previous question. If you have two questions in the comprehension, you would have asked the first part and the second part. You just cross check whether to compute the second part, whether the first part values are useful or not. If useful, just take it, grab it from there and just solve for the second part. Do not always compute it and compute each and every time wherever it appears. So no need of computation, because no need of finding, because we have it from previous question. So the only thing you have to do is just joint PMF value, which is straightly visible on the screen itself. So which is 1 by 4. So 1 by 4 by 3 by 4, which will give you this answer. Okay. Now the final question and the most trickier question on this particular problem. What is the probability that y is greater than or equals to 1 given x is less than 2? Okay. So this requires some sort of calculation. I request everyone to try this out, and then we are pretty much okay in terms of week 1, I guess.
Sir, is it 5 by 24?
Okay, one answer I got as 5 by 24. Let me make it as option A. So option A is 5 by 24. Any other answers? We'll add as an option.
5 by 24.
5 by 6.
Okay, option B is 5 by 6.
Yeah, 5 by 6.
Sir, 5 by 6 only. Sorry.
Okay. Okay. There is an option change from 5 by 24 to 5 by 6. But some other person has already said 5 by 24. I still keep option A. Any option C's, D's?
It's 5 by 6.
Okay. Any other answers other than this 5 by 6 or 5 by 24? Or you can upvote for 5 by 6 and 5 by 24 also.
So 5 by 6.
Okay. So looks like 5 by 6 is getting more votes. Anyone would like to challenge this 5 by 6 and say some answer? No? Okay. So how did we compute this? So the people who are unable to compute, just take a look at on the screen now. So what we have to do, again write it in terms of join divided by marginal. So in order to write it as join, I have to write it like this. Divided by marginal is probability that x less than 2. Okay. Now, what is this x less than 2 means?
1 minus x greater than equal to 2.
1 minus x greater than or equals to 2. Okay.
No, sir,
So what will that
the
be?
range
What
of
will
x
that be?
is 1 or 2, and for less than 2 means it is just only 1.
Right.
One,
So
yes.
that is how you should think of. See, when we said x is less than 2 probability we need. But I know the set of values that x takes is 1 or 2. So when can x take less than 2? Only possible case is 1. So therefore, the probability that x less than 2 is nothing but probability that x is equals to 1. So both are same. So the denominator got reduced to just probability that x is equals to 1.
Sir, can you just show the table just for a moment?
Okay. Maybe I will just bring the table down. I need the table. This we need it here. Not this lengthy. Let's keep this table here. Okay. Now x less than 2 is the probability that x is equals to 1. So in the numerator also we have y greater than or equals to 1, comma x less than 2 is the same event as x is equals to 1. Now what is y greater than or equals to 1?
1 and 2.
Same wise, you just do the same thing. So y is greater than or equals to 2. What is the range of y? You just look at the range of y, 0, 1, 2. Is it greater than or equals to 1? Okay. So when I said greater than or equals to 1, so that means y takes values 1 or above 1. So you just look what all values y can take in the range. So 1 it can take, 2 it can take, 0 it cannot take, because my y should be greater than or equals to 1. So that means y greater than or equals to 1 is same as saying y is equals to 1 or y is equals to 2. Okay. So therefore,
Sir,
this will be like, yeah.
here could we do 1 minus p y less than 1?
Y less than 1. Then it will be just y is equals to 0. That
0.
also can be done. Can be done.
Okay, sir.
So this will, the numerator now will be, now we have y is equals to 1 or y is equals to 2. That means at one time y is 1 and another time y is 2. So or should capture both the probabilities, or in some sense should add the probabilities. So one time you take y is equals to 1, x is equals to 1, plus the next time you take y is equals to 2, x is equals to 1 divided by probability that x is equals to 1. Now for computing probability that x is equals to 1, is it smarter to add these three values or look at the previous questions?
Previous question.
So since I have probability that x is equals to 2 is this, from here I can compute the probability that x is equals to 1, which is 1 minus 3 by 4, which will be 1 by 4. As simple as that. If you want to cross check, just cross check by adding 1 by 24 to 1 by 12 to 1 by 8. You'll just get 1 by 4. Okay.
Yeah, got it. It is very useful.
Okay, so now you just add enter these values from the table. So this value will be 1 by 12 and this value will be 1 by 8 and this value is 1 by 4. So 1 by 12 plus 1 by 8 divided by 1 by 4. This is 5 by 6. Okay. So yeah, let's move to week 2 then.
Sir. So वो multiple random variables पे conditioning जो डालते थे वो समझा देना.
Right. Thanks for reminding. Okay, let's before moving to week 2, let's slightly look at I just wanted to spend very less time on this. How can we split the joint into product of marginals and conditionals in a multiple random variable case? So now instead of 2 random variables, we have multiple random variables, and multiple random variables I don't want to talk on n. So I just want to talk on 3 random variables instead of 2 if you have 3. Okay, so x, y, z are discrete random variables. Now how can I split or make it into product of marginals and conditionals of joint? So before writing this, I will just write what has happened for 2 variable case. Then we can somehow connect it with the 3 random variables. Then you can connect it with the n random variables also. What has happened in a 2 random variable case? The joint, I have written it like this. So the first marginal of x times the second random variable conditioned on the first random variable. So this is in the 2 variable case. So the same extension I wanted to do for the 3 variable case. So what you do is you just take the marginal of one random variable. So fx of x times. Now since you marginalized one random variable, it should be product to the conditional and conditioned on the same random variable which you took as the marginal. So now condition it on the second random variable, which I call it as y. X is equals to x of y. Now times, so slight extension, we have the third random variable also. So you saw the first random variable, you just took the marginal of the first random variable. Now you conditioned on the first random variable, you looked at the probabilities of the second random variable. Now what you have to do is you should condition on the first and second random variables. You have to look at the probabilities of the third random variable. So which is this. So the third random variable is z, conditioned on y is y and x is small z. Okay, so this is how you can write the joint of 3 random variables as product of 3 values, which is the first one is the marginal, the second one is the conditional conditioned on x, y conditioned on x, and the third one is z conditioned on y and x. Okay. So this is all. So sometimes
Sir, how you
Can we
added
go-
the f of z part?
How
you added the last f of z part?
See, the thing is, I took in 2 variable case, I took x. Okay, so I have only 2 random variables. I have considered the marginal of the first random variable. That means I completely observed x. Okay, completely observed x, and somehow I am pretty much sure about x now. So I know how x behaves. So that is, if you know the marginal, you know what is the distribution of x.
Yes.
Right? Once you have complete control on one random variable, now you are looking at the other random variable conditioned on this random variable. Okay, in some sense. So y
Yes.
given x is equals to x is that. Now, if you have three random variables, what we are doing is we just observed the first random variable and understood the distribution of the first random variable. Now, next what we did is we try to understand the next random variable conditioned on the first random variable.
Okay.
Now we have to understand there is one more random variable coming in, and you just follow the same what you followed for the first two. So what you followed, you just observed one, completely understood the distribution of one random variable,
Yes.
and you just looked at the probabilities of the second one. Now, or the previous, using the previous random variables, you just looked at the probabilities of the current random variable. When I added the third random variable, what you have to do is, in order to understand this, since now you know how x behaves, how the distribution of x behaves, and how the distribution of y behaves given x, so both you know, now you can look at the distribution of z conditioned on x and y's. Okay, so
Yes,
that's
sir.
that is the third term we'll add.
Sir,
And you
so
can
the
generalize this.
multiplication of last two terms, will that lead to f of xy given x is equal to x?
F of, will this
f
lead
of
to
yz given x is equal to x?
f of yz given x is equals to x, yz.
In bracket y comma z.
Right. That in some sense that is how it will be.
Is my thinking correct?
Correct.
Okay, sir. Thank you.
Yeah. Okay.
Sir,
Hmm.
sir, can we also view this as the case that our sample space is getting reduced progressively?
Not getting reduced progressively. Yeah. You are looking the joint. Okay, maybe I can agree. Yeah, progressively it reduces.
Okay, sir.
Okay. Okay. That is about multiple random variables. So you can extend this argument to n random variables. I don't want to discuss that.
Sir, we'll be doing a sum on this.
Sir,
Okay, let's quickly do a
sir,
sum on this.
can we have an example for that?
Okay. So 0, 1, 1. Let's say this is given to be 1 by 10. So I'm just making up this example right now. Let me know if the probabilities go above 1. Okay. Then what will I do is I will just change it. Let us say this is 3 by 4. Sorry. X of 0. Something 3 by 4. So let's say find fy given z is equals to 1 of 1. Okay, very easy. What I have to do? I have to just, since fz of 1 is given to me, it is good to condition, just look at the marginal of z first. Write down the z first. So fz and z value is 1 times f. Next you look at, we have given that x given z is equals to 1 and y is equals to 1. So this is given to us. So that means x should be the last random variable to be observed. So since x is the last random variable, and between the second random variable should be y. Y given z is equals to 1 of 1 times x given z is equals to 1. Y is equals to 1. Oopsie. Is this expression okay to everyone?
Yes.
Okay. Now what we gave? This we gave 1 by 10. This we gave 2 by 5. and this we gave as 3/4, and we wanted this. Okay, can we compute this? Yes, no?
Yes, sir.
So take this as some small x or whatever, k. So this expression will cut down to 1/10 is equals to 2/5 times k times 3/4. So from here, what will be the value of k? Okay, no one is interested to
3 by
solve
10.
this.
No.
Do you think that this is an easy problem or?
1
No,
by
no. 3 by 10. It's 1 by 3. 1 by 3.
1 by 3.
Okay.
Yes, sir, 1 by 3.
So you wanted difficult question, then I can pose difficult question.
Sir, one question. Sir, sometimes when these f of x are given directly, it's a formula substitution, it is easier. I mean, relatively easier. Let me not use that word. But sometimes what I find as difficulty is a kind of a word problem is given, right? A ambulance arrives, and a queuing mechanism is there. From there, is there any tip? From there, how to extract and put into variables of x and y? That's where I feel the most troubled. Is there
Also
any tips
random
for that?
variable.
Oh, maybe.
I also feel trouble because our English is weak.
Okay, maybe from context to statistical expressions is what mathematical expressions.
Yes, sir.
is the con-
Yes, sir.
Okay, maybe not at this example. This example, no need of taking a contextual part. Maybe while we deal some sums of random variables and max min, when we do this function of random variables, there we can discuss this.
Okay, sir. Thank you.
Okay. So let's move to week 2. So week 2 starts with independence between two random variables. So let us quickly talk about what this independence between two random variables. So independence of random variables. So from now on, I don't want to consider multiple random variables, as I previously explained. I will just stick on to two random variable cases. If you want intuitions of n random variables, I don't feel this is the right time. We can have a detailed discussion post quiz 1 on multiple random variable case. But the intuition says the same. Two random variables case, you just extend it to multiple random variable cases. Okay. So independence of random variables, I just want to talk on two random variables, x, y. If x and y are discrete again, they are random variables. And when do I say two random variables are independent to each other? I say if
f of x into f of x.
fxy of x comma y is equals to fx of x times fy of y. For all, this is the important thing, for all x belongs to the range of x and y belongs to the range of y. Okay, so this for all is the most important thing. It's not for only one particular case. You have to check for each and every possible case. So then, if this happens, then I say x and y are independent to each other. Okay, so inverts this expression. Okay, so this expression is nothing but the joint PMF is equal to the product of marginals. That's how you should read that particular expression. So this is one condition. So the same kind of condition, so which comes from this particular condition, you can derive another condition for checking the independence thing. That is when this conditional PMF is same as marginal. Okay, so joint PMF is equal to the product of marginals, or in other words, conditional PMF is same as marginal PMF. Both are same. This says fxy, fx given y is equals to y of x will be fx of x, and fy given x is equals to small x of y is fy of y. Okay. If this happens, then also we say x and y are independent to each other. So condition doesn't impact much on the probabilities. That means if you condition it on x and you look at the probabilities of y, it is same as looking at the probabilities of y individually in some sense. So x is not impacting on y. There is no impact of x on y, and there is no impact on x of y. So what did I say? Impact of there is no impact of x on y. There is no impact of y on x. Okay, sorry. So that is how independence thing comes into the picture. There is no dependency between the random variables. That's why we call them as independent. So when do I say they are dependent? So that's also a question to ask, right? So independence, in order to conclude that x and y are independent, you have to check that condition. So for dependence or maybe not independent, what you have to do is, if you have to check this, if your joint PMF is not equal to the product of marginals. Now this time it's not for all, it's for some. For some, I mean at least for one xy, if you can come up with a pair of x comma y such that this is not happening, for some x belongs to tx and y belongs to ty. So what it means is, if you can come up with some small x and small y such that the joint is not equal to the marginal, then I can claim that they are not independent. So then I can probably conclude then x and y are not independent. Okay, so let's take an example. So let me say this example 3. Okay, so again, given a joint PMF table, okay, so this side is x now, this side is y. Y takes values 0, 1, and 0, 1, 2. Let's increase one more value for y also. Okay, so let me call this 2, row 2, and take the values to be 1 by 6, 1 by 12, 1 by 12, 1 by 12, 1 by 24, 1 by 24, 1 by 4, 1 by 8, 1 by 8. Now the joint PMF table is given to you like this. Now the question is x is independent of y? So in some sense it is same as asking for whether x and y are independent to each other or not. Okay, take a minute and
Yeah, it is independent.
it is independent. You have to check 9 entries.
One entry is enough.
No, 1 entry is not enough. I said 1 entry is enough when the table is just 2 cross 2. Now the table is 3 cross 3. There are 3 rows and 3 columns. So go back to the condition. What I said? I said for all, in order to check for independent, in order to conclude that X and Y are independent, you just have to check all the entries.
Yes,
For
yeah,
each and
got
every
it.
X. But if you want to just break that independence thing, it is enough to check 1 entry. Any answers?
Independent.
Okay. Okay, do you guys need a break?
Yes,
I
sir.
just
A
saw
short
Saiteja,
one.
sorry, I just saw your message now. Okay, maybe 5 minutes, but we are running very short of time. So we will.
It's already 9:30.
Yeah. So people who wanted break, you can take breaks when other people are trying to solve. Try solving the problem as early as possible and then just take a break.
Yes, sir, it is independent.
Okay. So it will be independent. So the thing is, what we have to do is we have to check whether the joint is equal to product of marginals or not. So for that we need marginals first of all. Let's try to extend our table by adding 1 row and 1 column. So if I add, I can append the values of marginals. So now this will be Fy or Fx? Yeah.
Fy.
Y.
Fy.
This will be Fx of x. Okay. So just add 1 by 6, 1 by 12 plus 1 by 4. So this will be half.
Yes, that
No.
is
Half.
4 by 12.
1 by 3. 1 by 3.
6 by 12.
6 by 12.
6 by 12. Half.
Yes,
So
sir.
half.
1 by 2. Yes.
See, again, I said 1 by 4 plus 1 by 2 is not 1 by 6. Okay.
So 1 by 2, 1 by 4, 1 by 4.
So this will be, if you add this 1 by 12, 1 by 24, 1 by 8, you will
1
get
by
1
4.
by 4. This will also
This
be
is
1 by
also
4.
1 by 4.
So
And
this
this
will
side
be
is 1 by 3.
1.
1 by 3, 1 by 6.
1 by 3, 1 by 6, 1 by 2.
1 by
Yes,
6,
sir.
1 by 2. So now what you have to do, you have to take this value and this value. You just do the product of these two and just check whether that is being equal to this or not.
Yes.
So that is one case. So yes, this is happening. So give a tick mark to that particular entry. So like this, proceed to the next one. 1 by 3 times 1 by 4 is 1 by 12. Give a tick mark. 1 by 4 times 1 by 3 is 1 by 12. Tick mark. So like this, it should satisfy all. So all the entries should be tick marked. So if one entry, if you get something like cross or it is not satisfying, so if this entry is not satisfying, then it is not independent. Okay. So this is how you check for independence thing. And okay, maybe a cheat code, cheap trick you can use here is if one of your entries is 0,
it's not independent.
One of the entries in your joint PMF table is 0, then they are
And the
not
marginal
independent.
is not 0.
Then they are not independent. Yes. Okay. So you can use of this as a cheap trick, but again, Having said all of these things, we will not be giving a joint PMF table which has 0 in it and asking for whether they are independent or not. In a big problem, you can use this as a smaller part. You can use this as a smaller part. Okay, so that's about independence. So once independence is done, we will just move to a bigger brother of independence, which is independent identically distributed. So it will have an extra condition added to it. Yes.
Sir, you have mentioned conditional PMF is same as marginal PMF. With this example, can you?
Okay. So we can do that also. One example. Okay, I'll just take one example.
Okay. Sir.
So let's try to compute Fy of x is equals to 1 of 2. Okay. So what is this? This is Fy is equals to 2 comma x is equals to 1 divided by Fx is equals to 1. Maybe probability. So what is the probability that y takes 2 and x takes 1? Go to the row 2 and column 1, which is this value, 1 by 8.
8.
Right? So 1 by 8 divided by, what is the probability that x takes 1? 1 by 4.
Yeah, 1 by 4.
Which is?
1 by 2.
1 by 2. And what did I say? This should be equal to the marginal Fy of 2. Is it, what is Fy of 2?
1 by Fy of 2.
Fy of 2. This
1 by 2.
1 by 2.
Yeah, the last one.
They are equal. You can check for other entries also.
Okay. Okay. Thank you, sir.
Okay. So let's move and talk about this independent identically distributed. So this has two conditions. So we have if we have some n random variables, let's say x1 to xn, then we say these n random variables are independent and identically distributed. We say these are IIDs basically if it satisfies two conditions. The first condition is independence condition, which just now we discussed, which is the joint should be equal to product of marginal. So that means fxy, or here we have n random variables. So fx1 x2 to xn is the joint, x1 x2 xn. This joint should be equal to the product of marginals. So when I say product of marginals, it should be fx1 of x1 times x2 of x2 times and so on, fxn of xn. Okay. So firstly, they need to be independent to each other. So this is the condition for checking independence. The next thing is their marginal PMFs are identical. Identical, or I can also say same. Okay. So the marginal PMFs, I mean, when you compute the marginal PMF of fx1 of x1, this should be same in the sense, or whatever the PMF it has, the same PMF.
Sir, same or equal to?
Equal to can't say, right? See, you can think of equal, but it's not a value to just say equal. It's
Why,
a function. Sir? It's a function. See, marginal PMF is a function, right?
Yes, sir.
So function equal to function is not that.
Okay. No, function value equal same.
Function value should be same.
Yes.
So identical to the other PMFs. Okay. So if you compute the PMF of, so the example I have it below. So you will get more sense on what this identical means in the below example. So let's say x1 to xn follow IID Bernoulli 1 by 3. Okay. So what does this mean is, whatever the joint you have, that can be written down to product of marginals. So if you take T1 or x1 or whatever, let's stick to the same notations we stick till now. So x1 to xn. So this will be product of marginals product fxn of xn. And saying that the marginal PMFs are identical means whatever the distribution this Bernoulli 1 by 3 has, x1 will have the same Bernoulli 1 by 3, x2 will also have the same Bernoulli 1 by 3, xn will also have the same Bernoulli 1 by 3. So that's the sense of saying identical means. Okay. So you know the PMF of x1? What is the PMF? So 0, 1, probability that x is equal to x, 0 with probability 2 by 3, 1 with probability 1 by 3. So this is the PMF of x1. So the same PMF will hold for x2, x3 and so on xn also. Okay. So that is what IIDs means. So it should be independent to each other, and if you compute the marginals also, they are more or less be identical or same. Okay. So this is an example. Let's suppose say x follows 0, 1, 2 with probabilities 1 by 3, 1 by 2, 1 by 6. Did we do the same example in the previous week 2 when we are doing week 2? This is the same example we took. Okay, no. Anyway, let's try to quickly solve this and just move to the functions of random variables. So right now it's not Bernoulli 1 by 3 or any other well-known distribution. A distribution is given to x, and suppose we said x1 to xn. Let's cut this down to x5. Okay, x1 to x5 are IID samples with distribution x. So what does this mean is, this means that x1 to x5 are independent,
but they are not identical.
Why they are not identical? They are said to be IIDs.
Oh, okay.
So this also says x1 to x5 are identical. Okay, so IID will, that very 3-lettered IID has this much things, these many things inside. Okay, so let's try to solve this. Once they are independent, so this is just a joint. Once they are independent, I can write it as product of marginals. I can break down that big expression to product of smaller things. x5 not equals to 0. Now, where this identical thing will help you is the next step. So here you have used the independence thing. Okay, so independence thing, and you just break down the joint, big joint, into product of margins. Now in the next step, we will use the identical thing here. So if I use that identical, that x1 to x5 will have the same PMF, that means all the probabilities that are computed on one random variable on the same event will be same for all the other random variables.
So uniform distribution, no? Is that
It's
called?
not uniform distribution. So
Okay.
here it is not uniform. It's not uniform what I said. See, if x1 is following some distribution, then you can compute, you can define an event. Right now the event is x1 not equals to 0. It's an event.
Okay. Okay.
So you can compute the probability of it.
Can we make all x2 not equal to 0 as x1 not equal to 0?
Right. So that's what you can do. That is what you can do. So if you compute this particular probability and this particular probability, this will be same because their marginal PMF are same. So their probability mass functions are same. x1 have the same probability mass function that x2 has, x3 has, x5 has. Once we have the same PMF, same distribution, it's like same distribution, the probabilities on that particular distribution will also be same. So you can simply replace this with x1 not equals to 0 times probability that x1 not equals to 0 times and so on, x1 not equals to 0. So here I have used this identical PMF, marginal PMFs. So if they have identical marginal PMFs, then the probabilities will be same on any same event will be same. So here the event is not equals to 0. The random variable not equals to 0 is the event. Okay. So this is
Sir?
how many times this? Yeah.
The second I stands for same probability distribution function of all the random variables.
Right. So
Okay,
this
sir.
is 5 times. So this will be x1 not equals to 0 whole power 5. This will be probability that x1 not equals to 0. Now x1 also follows x. It will also follow x. Samples with the distribution x. So therefore this will be probability that x not equals to 0 whole to the power 5. So you know what the distribution of x is. So from here, what is the probability that x not equals to 0?
2
2 by 3.
2 by 3.
So which is probability that x is equals to 1 plus probability that x is equals to 2. So you just add 1 by 2 plus 1 by 6, you will get 2 by 3. Or just do 1 minus of 1 by 3.
1 minus.
You will get 2 by 3. So that also.
Sir,
Right.
coming back to what I said,
Hmm.
this is where my terminology needs to be corrected.
Mhm.
So you said, here x takes 0, 1, 2, and we clearly said x not equal to 0 is 2 by 3. How did we get that? It is all the probabilities are same. So 1 by 3, 1 by 3, 1 by 3, right?
No.
No?
See, here the probabilities are 1 by 3, 1 by 2, 1 by 6.
Okay. That part I
The
missed.
above, okay. Maybe I
Okay.
should
Sorry.
have said
My
that. Yeah.
Okay. I missed that part. Okay, so it is 1 by 2 plus 1 by 6.
1 by 2 plus 1 by 6 luckily happened to be 2 by 3. That's it.
Okay, got it. Okay,
I
that's
have framed out this x is 0, 1, 2, and all the distribution are given different.
All the distribution? Probabilities are different.
Probabilities are different. So
Right.
distribution and probability are same, na?
Distribution and probability for each and every possible value is same.
Same. So if we take x equal to does not equal to 0, x does not equal to, x2 does not equal to 0, it means if we take x1 equal to x1, x2, x3. Okay.
Everything will be same, right?
Yeah.
See, we said x1 follows x, where x follows this. So that means x1 follows this. x2 also follow the same thing. x3 also follow the same thing. So if you compute the probabilities, you are more or less computing on the same distribution. Okay.
Yeah, the answer is 2 by 3 whole power of 5, right? Okay.
Right. Answer is 2 by 3 whole power 5. Okay. So with that note, I just want to close IIDs here. Let's move to the final discussion for today's session, which is function of random variables. Yes, Rohini.
Sir, I just wanted to know whether this will be available. This session will be available on YouTube.
On YouTube, yeah, it will be available. It is right now. It is streaming online, live.
Okay. But it is being recorded also. No? Okay, thank you, sir.
Okay, so the final discussion for today is on function of random variables.
Sir, can you just share this PDF?
Okay, I'll just share this PDF. So in particular, I just said I will discuss 4 main functions. The first one is x plus y, simple x plus y, and this time I will take the distributions of x and y to be different. Okay, different in the sense, let me say x follows binomial 3 comma 1 by 3, y follows Bernoulli 1 by, okay, let's not take 1 by 3, 1 by 4. Okay, So x is following binomial 3 comma 1 by 3 and y follows binomially 1 by 4. The question is find fz1. Small. So what am I asking for? I'm asking for PMF of z.
So this is not a joint PMF. We cannot use the name as joint PMF.
No. It's not a
No,
joint.
this is not joint PMF.
This is not
Okay.
joint. This is just summing two random variables. I'm just
Okay, function
adding
of,
two random-
okay,
yeah, function of two random variables. So again, in functions of random variables also, I'm going to take only two random variables, not more than that. Okay. So how do we do this?
So first we have
So-
to write the range of
Range.
x and y.
So what will be the range of x and range of y? Range of x?
0, 1. 0 and 1.
X. Range of x.
0, 1. 0, 1.
It is binomial.
Binomial.
Will it start from 0 or 1?
0, 1, 2, 3.
Yeah. 0, 1, 2, 3.
Yeah.
Some said 1. Binomial starts from 0, 1, 2 till n. Here n is 3 for us.
3.
0, 1, 2, 3. What is the range of y?
0, 1.
0, 1.
0, 1. Because it's binomial. Okay. Now we have the ranges with us. Next what?
Make table. Add them.
Range of z.
That's good. So from the range of x and y's, you try to compute range of z1. So for getting that, it's good to write down in the form of table. So you take x, you take y.
0 to 4.
Okay. You just take each and every possible value of x and y's, possible combinations. So 0, 0, 0, 1, 1, 0, 1, 1, 2, 0, 2, 1, 3, 0, 3, 1. Okay. Now need z. What is 0 plus 0? That is just x plus y. 0 plus 0 is 0. 0 plus 1 is 1. 1, 2, 2, 2, 3, 4. Now you can clearly see what are the possible values that z1 takes is whatever the values, distinct values you observe in this particular column. So that will be your tz, the range of z1, which is 0, 1, 2, 3, and 4. Okay, so far so good. So we got the range. We are yet to get the probabilities.
Probabilities.
2, 1 is going to be 3, sir.
Just a second. I should have mentioned this thing also. X and Y are independent to each other. Just the independent, they are not identically distributed. Okay. Now, what is
row 2, 1? Row 2, 1 is going to be 3.
Row 2, 1. Huh? Row 2, 1 means this one.
Yeah, it's z plus 3.
Yes, sorry. Yeah. Thanks. So this will be 3. Correct. So now this is 1, this is 2, this is 3, this is 4, 1, 0. Now we have to find the probabilities also. Let me, since I said they are independent to each other, Joint, you can write it as product of marginals, fx and fy. Now, what is the probability that x takes 0 and y takes 0? Okay, let us write it here. X follows 0, 1, 2,
1 by 8.
3. 0 with probability
1 by 4.
1 by 4. 3c 0 times, just use the formulas you have. 1 by 3 whole power 0, 2 by 3 whole power 3. Right. So that will be 2 by 3 whole cube. Correct? Yes, no?
So if they mentioned this as a uniform distribution, then it would have been 1 by 4. Now it's a
They
binomial.
mentioned that it is binomial. See, I clearly
That's
gave
what
x
we're
follows.
doing. But if had they mentioned it as uniform, then we could have taken it as 1 by 4.
1 by 4, yeah. So use this binomial. Again, for 1, what you have to do? So this is for 0.
3c1 into 1 by 3 to the power 1 and 2 by 3 to the power 1.
Right. So 3c1 into 1 by 3 whole power 1 into 2 by 3 whole power 2. 3 minus 1, which is 2. So this will be 4 by 9. 4 by 27. Sorry, 4 by 9. So this will be 3 times 1 by 3 times 4 by 3 square. So this and this will cancel and it will be 4 by 9. So similarly for 2, it will be 3c2 1 by 3 whole square 2 by 3 whole power 3 minus 2, which is 1. So this will be 4 by 9 again. And the last one is 3c3 1 by 3 whole power 3 2 by 3 whole power 0. So this will be 1 by 27. This is 8 by 27. Okay, so this will hold be 8 by 9 plus 1 by 9, which will give us 1. So these are the corresponding probabilities. Okay,
2 by 9.
Which one?
Probability of x equal to 2. It's 2 by 9, I think.
Okay, is it 2 by 9? So 3c2 is 3.
2 by 9.
Yep. 2 by 9.
Yeah. So this will be 1 by 9 into 2 by 3. So this and this will cancel and 2 by 9. Yes, correct. You are correct. 2 by 9. So this is okay. And y is very simple. I think everybody knows this. Y follows 0, 1, 0 with probability.
1 by 2.
No.
3 by 4, 1 by 4.
3 by 4.
3 by 4 and 1 by 4.
Yes.
Okay, so these are the probabilities. Now it's very easy to compute the joint. So 0, 0 is like 8 by 27 times 3 by 4. Right? Just do the product of marginals. So similarly, fill this table. Once you fill this table, let me fill few more entries. So 0, 1 now. It will be 8 by 27 into 1 by 4. So from next, I will just simply write down the values. You just cross check. 4 by 9 times 3 by 4. This will be 4 by 9 times 1 by 4. And so on and so forth. Okay. And maybe I will write for 3's. So 2 and 1 will be x is equals to 2 is 2 by 9. So 2 by 9 times 1 by 4 and x is equals to 3 will be 1 by 27 into 3 by 4. So something like this. So you can just fill the table. Just do the product of marginal probabilities. You will get this column. But this column is not the PMF of Z1. So what you have to do is you have to pair up or add up few values. So 0 has only one column. For Z1 is equals to 0 is only one value. This is the only value, and that will be the probability that Z1 is equals to 0. But for 1, 2, 3, we have 2 rows. So for 1, you just have to add this probability with this probability, and that whole sum will be the probability of Z1 is equals to 1. Similarly here also, for 3 also, if there are 2 rows for 3, you just add these two values, and then that will be the probability for Z1 is equals to 3. Okay. Okay. So now this is okay.
Yeah, it's clear.
So that is how for sum of random
I-
variables you have to compute. Yeah.
I have one question. Like, when we check the range of binomial, as that number is 3, for that reason only we are using range up to 3, right? Like,
Up to 3, right? Yeah.
Okay.
See, that 3 represents binomial always. See, look at the
N.
distributions always with some practical application. So binomial distribution is like you just do your experiment some n times, and you just check the number of successes in your n experiment, n times you perform the experiment.
Okay. So 3 represents number of times our experiment, and 1/3 represents the success or probability.
Success probability, and x value that x takes represents the number of successes you got.
Okay, got it. Yeah.
Okay. So you may not get any success, that represents 0. And since you are doing only 3 times, you are performing your experiment 3 times, you can at max get 3 successes. So that is why the range of binomial is like that. Okay. So
can you show the table, sir? Please, the function table. Yeah, that one.
This one.
Okay. So z is x plus y. We have to see wherever it is 0. Take that. Okay. All right. Thank you.
Okay. So this is if it is sum. If it is product, there is no change in the first 2 columns. There will not be any change. Even the third column will also be the same, but the values that it takes will change. X, y. If I change the function, the range of that particular function might change. For example, this is what if I consider my next function to be xy, simply the product of 2 random variables. Okay, so let me take these things. Let's see here. Okay, so if I said now z2 is the product. Now what will be the values be? X times y. When 0 0 it will be 0. 0 1 it will be 0. 1 0 also it will be 1 times 0 is 0.
1.
2 0 will be
Now comes
0.
1 times 1 is 1.
1.
2 times 0 will be again 0. 2 times 1 will be 2. 3 times 0 will be 0. And 3 times 1 will be 3. So now the range of Z2 is...
One more is left, no?
One more is left. Huh? There are 8 entries, right? 8 rows. 1, 2, 3, 4, 5, 6, 7, 8. All captured.
Now range is 0, 1, 2, 3.
So now the range will be 0, 1, 2, 3. Okay.
So 2 2 is left, no?
2 2 will not come, right? Because y can take only value 0 and 1.
Oh, 0 0. Right.
Okay.
Right.
So now what you have to do? The same thing you have to do, but the number of rows you add for each value might change.
Yeah.
What happens here is
1, 2, 3, 4, 5. 5 of zeros.
Huh.
5 of zeros hold the probability of 8 by 27 into 3 by 4.
1 and 2 and 3 will be only single.
Right. So you just look at 0. There are 1, 2, 3, 4, 5 zeros. So what you have to do is you have to take that particular row probability, this
And add.
probability, this probability, and somewhere in between this probability and this probability. No, not this. Some probability. 30, you just let me compute 30. 30 is 1 by 27 times 3 by 4. Okay. So this probability. So what you have to do is, for getting Z2 probability that Z2 is equals to 0, you have to add all these 5 values, and that will give you for 0. And next we have 1, we have 2, 3. But 1, 2, 3 has only one row. You just take that particular probability, that particular row probability.
Sir, how do we read whatever we said? If we need to, we are saying we have to add all these probabilities. I get that, but how do we say that? Should I? I mean,
in words, what that means is, see, we are interested to get the probability that Z2 is equals to 0.
0.
So that means, what are all the possible cases that Z2 can be 0? What are the possible cases? Product is becoming 0.
Product is becoming 0.
So that means either X is 0 or Y is 0. Right? X can be 0, Y can be 0.
Be 0.
Then also Z2 0.
Correct.
When X is 0, Y is 1. Then also Z2 is 0.
So in terms of probability, we say and or, right? In this case, it is or.
Or, right.
Okay.
See, what is the possibilities for Z2 being 0? One case is 0, 0, or 0, 1, or 1, 0, or 2, 0, or 3, 0. In all these possible cases, the product will be 0.
0.
So therefore, we add each and every corresponding probabilities, possible cases, probabilities. Okay.
So in this example, we touched upon the Bernoulli formula, the combination Bernoulli also we touched, right?
Yes.
Bernoulli binomial, and then we computed the function, and then corresponding probabilities that Z will take.
Right. Right. Okay. So that is about sum and product. So now for the final topic for today is a random variable can also be defined on function of two random variables, and this max and min also is a function basically. When Z3 is max of x1, x, y, what does that mean basically? How do you interpret it, or how do you see that max of x, y as a function? So what that means is, again, function is always, think of like this. It's a machine, big bada machine, where there will be an input, and this is the function, some function f, there will be output. So this is what function means.
So instead of x and y, both the values, we'll just take out whatever the
maximum of it. Correct. So now, why this max of x, y is a function? Because we are just inputting x and y into this max function. It takes, it does something, some black box. We don't know what it does, and it just gives output as, it just compares x and y, and whichever is greater, it will just throw it as an output. So that means x will come as an output if x is greater than y, or y will come as an output if y is greater than x. So this is very easy to observe. So that is how you can look at this particular
No, but
max of
sir, if X and Y are equal,
whichever comes out, it doesn't matter, right? Both are maximums, X or Y, and both they are equal. When X is equal to Y, you take X or Y. Both are anyway equal. Right.
So we have to take the probability for both X also equal to 0 and Y also equal to 0.
See, the
When
thing
you
is,
are making the table,
right. When
we have to
max of
take it
1
twice,
comma,
no?
no, not twice. You will not do twice. See, max of 1 comma 1. What is maximum of 1 comma 1?
1.
1. That's it. No need of.
But then the probability of which variable do we have to take?
It's not probability at all. See, the thing
No,
is, it's
when
a
we
function.
No, when we have to calculate for Z.
See, for Z, what we did we look at these first two columns?
No, we took the X is equal to 0, the probability of X is equal to 0, and multiplied it with
Probability of Y, right?
Of Y. So when we are taking max of X comma Y, which one do we have to take?
I understood your problem, but the thing is, think of it like this. So for computing this column and this particular column, we used X and Y, right? These first two columns. But later, for getting the distribution of Z2, did we go back and see which X we took, which Y we took?
No, we took X is equal to 0 and Y is equal to 0, no? The probability of X is equal to 0 and probability of Y is equal to 0.
0, then Z2 is 0, right?
But
That
Z2 is 0. But
That
then
is
calculation is of probability of X is equal to 0 multiplied by Y is equal to 0.
That is one case, right? That one case, you got the probability and you got the corresponding Z2 value also.
Yes.
Right? Like this, you compute for every case. Right?
Yes, but when in this Z3, when we are taking max of X and Y, like here we are in the Z2 case we are multiplying, or in Z1 we are adding the probabilities.
Okay,
here
maybe
do we have to take for X is equal to 0 and Y is equal to also 0?
I think this column,
when we are making the column for Z3.
I understood actually what she's telling. So we are not adding or multiplying the probabilities. To get the range, we are doing addition or multiplication. To get the probability, we are just multiplying because they are independent. For getting the range only based on the function, you are doing the thing. Like, if the function is X plus Y, you will be adding X
the
plus
two
Y.
probabilities.
Yeah, that is to get the range. Once you get the range, then you will, whatever the function, you will just multiply because they are independent.
Okay, maybe you will get a clarity once we compute this.
No, but the Z3 max of 1 0 0 when we are taking.
Let's compute this and let's see. Just a second. Let us compute this and then see whether we are able to get the answer or not. If we are not able to get the answer, then we will think how to compute the answer. Okay. So now let's try to get Z3 values first. Just let's try to fill this Z3 values. So what is max of 0 comma 0?
0.
So Z3 is max of X comma Y. So 0 comma 0 will be 0.
Yes.
What is 0 comma 1? Max of 0 comma 1.
1.
1 comma 0.
Again 1.
1. 1 comma 1.
1.
2 comma 0.
2.
2. 2 comma 1 is 2.
2.
3 comma 0 is
3.
3 comma
1 is equal to 3.
Okay. Now we got the range. What is the range of Z3?
0, 1, 2, 3.
Right. 0, 1, 2, 3. Okay. Correspondingly, we will compute this probabilities. Okay. Now what are the probabilities for getting 0 and 0? Okay, let's bring the table.
8 by 27 and 3 by 4.
8 by 27 and 3 by 4. Let's bring this first 4 values at least. So these will be our first 4 values. Right? 0, 0 is 8 by 27 times 3 by 4. 0, 1 is 8 by 27 times 1 by 4.
Yes.
4 by 9 times 3 by 4 is 1, 0, and 1, 1 is 4 by 9 times 1 by 4. So like this, we can also fill the next entries also. Okay. So let's not worry about that as of now. Let's keep it like this. Now we are worried about what will happen. Now I just want the probabilities, right? Probabilities that each Z3 possible value that Z3 takes corresponding probability. So that means 0, 1, 2, 3 I have as my range. I want with what probability 0 it takes, with what probability 1 it takes, with what probability 2 it takes, with what probability 3 it takes. That's the only thing I am left with, right? Now how many rows do we have that Z3 is equals to 1?
3.
3 rows. So if we have 3 rows for Z3 is equals to 1, what did I said previously? In order to compute probability that Z3 is equals to 1,
we'll have to add, no?
We have to add. So the same thing we will do here also. What you will do is you will add this probability with this probability with this probability. Okay, if you add these 3 probabilities,
that will correspond to
you
1.
will get probability that Z3 is equals to 1. So at any point of time, did we use whether X to be taken or Y to be taken in the case of 1, 1? So while computing probability that Z3 is equals to 1, did we use whether to pick X or Y, and did we struck at any point of time while we compute the probability?
No,
right?
No.
Okay. Is this clear?
Yeah, I think this multiplication of f of x and f of y is done, as somebody said, it is done because of the condition you had given that it is independent.
Right. That's why we multiplied the probabilities. If independence is not given and table is given, then you should compute in different way.
No, my question was something different, sir. What I was thinking, when we take Z3 is equal to maximum of X and Y, I was feeling that the probability of 0, if X is 0, is to be taken, or probability of Y is 0 is to be taken. And then
what did we use here?
No, here what we have done is we have taken the probability of f of xy.
Okay, maybe this will clear. See, the thing is you are worried about Z3 is equals to 0, right? Okay.
So what I was thinking was Z3 will have to be taken twice, because once the max will be for X and once it will be for Y.
No. See, what is the possibility that Z3 takes 0? Becoming max value itself 0. What is the possibility? See, we have Z3 to be max of
both are 0.
X and Y. So you have 0 to X and Y to be something greater than 0. Can the max be 0?
No.
No, if Y is greater than 0, then the value of Y will have to be taken.
Then the value of Y will. So what is the possibility that maximum being 0?
Maximum of x and y has to be 0, which means either both are 0.
Is it either both are 0 or it should be both should be 0?
Both should be 0. Both should be 0.
Either of them has to no, either of them has to 0.
No.
That is what I was thinking.
No, that's not the case, right? See, what is the max of 0 comma 1?
Is
1.
Is 1, not 0. So it's not either. See, if Z3 has to be 0, then X and Y need to be 0. Both should be
Both
0.
have
Then
to be
only,
0.
then only it will be 0.
Because X and Y cannot be negative.
The ranges we gave here
Range has to be
doesn't
positive.
In this particular case, range is not negative. So
Huh.
the only possible
One-
case is 0, 0.
One
So that
question.
means, yeah.
Yeah.
Just
Sorry.
let
Yeah,
me
go ahead.
finish
I
this.
will ask.
Okay. Just
Yeah,
let
yeah.
me finish this. In order to Z3 should take value 0, both X and Y to be 0. So what do I mean by both? X should be 0 as well as Y should be 0. So you have to take the probability that X takes 0, at the same time Y should also take 0, joined between 0, 0. That's the first row. Okay.
That's
And
the
when it comes to Z3 is
1,
equals
1.
to 1. Now let's talk about Z3 is equals to 1. Okay. So you have range of X to be 0, 1, 2, 3. Range of Y to be 0, 1. Now, I said Z3 to be max of X comma Y. When can the maximum be 1?
Either X is 1 or Y is 1. And
Either
the
X
other one
is
has
1
to be 0.
or Y is 1. And the other
And,
one should be less than 1.
Should be 0.
So less than 1 more or less in our case is 0.
Hmm.
So X is equals
If
to
X
1
is
or
equal to 1, then Y is 0. And if Y is 1, X is 0.
X is 0. Are
Or,
these only two
or
possibilities?
both can be 1.
Or both can be 1. Right? So you look at the probability that what is the chance that this occurs? What is the chance that this occurs? What is the chance that this occurs?
Yes.
And if this is a OR case, like it can be this or this or this.
Or this.
So then you have to add these three probabilities. And in table also we did the same thing. So row 2 is 0, 1. Row 3 is 1, 0. Row 4 is 1, 1.
1, 1. Right.
Now,
Okay. Thank you, sir.
Okay.
Thank you,
yeah, the doubt. Someone.
Yeah. So already the doubt was asked. Like, as you mentioned here, the function or regarding probabilities. So they both are independent. For that reason, we have
Multiplied the
multiplied.
probabilities. Right.
Yeah. If they are not independent or they are dependent, can you? I mean, just show for 0, 1 or something like that. Like how can we calculate that for our? Is
Okay.
it possible?
Okay.
Yeah.
Okay. So maybe I will just take some 10 more minutes. Let's end this session by 10:30. Will that be all right to everyone?
Yes, sir.
Or getting sleepy? No one had.
No. Please go ahead.
Okay.
Very.
Okay. So let me just try to give visual interpretation of max and min. This will help you, even though they are not independent. If they are not independent, then either the joint PMF table will be given to you or the function will be given to you. Probability mass function will be given to you, right? Just like example 1 and example 2 previously we discussed. Now, even the joint PMF table is given to you. Okay, if the function is given to you, you can compute the joint PMF table. So let's assume that we have a joint PMF table for now. I take my very old friend 3 case. So that's an independent thing. Okay, let's make one entry to be 0, and so that this will not be independent. Page. Let's consider this thing with some values we will change. Okay, let's not bother about. Okay, I will change these values only. So we have subtracted 1 by 8. Let's subtract 1 by 6 also. Okay, so what we will do is we will just make this entry to be 0, and we will add this 1 by 8 plus 1 by 6 will be 7 by 24. So this will be 7 by 24. Okay, so this is not independent. Agreed, everyone?
Yes,
This will
because
not be
0 is-
independent. Because 0 is there, this will not be independent. Now, it is asked to compute probability of maybe the Z3 is equals to 1 or 2, maybe 2. Okay, let's start with 1 and then just go to 2. So Z3 is basically max of x comma y. Now what is the probability that Z3 is equals to 1? That means how many possible cases are there to get the maximum value between x and y to be 1? This was
3.
discussed above also. There are 3 possible cases, whether x can be 0, y can be 1, or y can be 0, x can be 1, or both x and y can be 1. So on in the joint PMF table, you just identify what are they. So x0, y1. So x0, y1. This entry. Yes? Am I correct?
Yeah.
This probability. This probability. Okay. So this thing can be the same as 0, 1. Or we'll convert to plus.
Yes.
y0, x1 plus x1, y1.
1 by 12.
Okay, so now x0, y1 is this. Let's identify y0, x1 also. Where is y0? y0, x1. This. And x1, y1. Where is that?
1 by 24.
Center one. Right? Okay. So if I ask for z3 is equals to 1, where the function is given to be max of x comma y, these 3 values came. So these 3. In some sense, these 3. Now what if I had asked for, just forget about the table, probability that z3 is equals to 2. So the range of x is 0, 1, 2. The range of y is 0, 1, 2. So I had asked for probability that z, or maybe what are the possible cases that z3 being 2?
5 cases.
So when can z3 be 2?
0 to 20 11.
0 to 20.
So one thing is either one of them should be true 2.
Correct. 2.
Then only max will be 2. That is for sure. So
That's
first
right.
case, what you assume is x takes 2 and y should take less than 2. Y takes less than 2. Y can take 1. This can be one possibility. Or x takes 2, y can also take 0. So this is also another possibility when x takes 2. Or now y can take 2, x takes 1, or y takes 2, x takes 0, or there could be the final case, both can be 2. So there are 5 possible cases. So let's go back to the table and identify what are those 5 possible cases. Let's highlight it with pink maybe.
So
So, sir, basically you are saying that if the random variables are not independent, then there will be a table
given to us. Then only we can compute, right? Joint should be given to us. Joint should be known.
Yeah, okay.
Either you have to construct it or it will be given.
So we might be giving you a function. From function, you can construct the joint PMF table, or maybe joint PMF directly might be given to you. So these 5 cases are these 5.
We can calculate, sir.
So I will not calculate. Don't worry. So these 5 cases. Okay. Now you can see some pattern when something from the table. So for z is equals to 1, these 3 values got added. For z is equals to 2, z3 is equals to 2, these 3 values got added. Okay. If I had a table with more entries, okay, so maybe x on this side, y on this side, 0, 1, 2, 3, 4 and so on. 0, 1, 2, 3, 4 and so on. There might be some values fx wise. Each and every entry will have some value between 0, 1, and if you add up all the entries, you will get 1. But that's not what we wanted. What I wanted to see is how this max behaves. So z3, which is max of x comma y, I wanted to see.
The intersecting rows and column align, like fifth row and fifth column, all the values across these boxes will add up.
Right, exactly correct. So the thing is, for 0, you see, you go to the first row, first column. You just add up all the values till the intersection point. Okay, but here we have only one case for 0. This will represent z3 is equals to 0. For 1, you just go to the 1 row and 1 column and add all the values. And for 2, it will be like this. 3, it will be like this. 4, it will be like this. So this will be z3 is equals to 1, z3 is equals to 2, z3 is equals to 3, z3 is equals to 4. So like this, each and every, for 2, there will be 5 values. For 3, there will be 7 values. Okay, like this. Okay. Then, yeah. Any doubts? Yeah.
Can you write those special cases, like when in sum, when random variable is like Bernoulli and we add, then it become binomial with n comma p, and with Poisson also when we add, they become another thing with the same Poisson. Those distribution, can you write those special cases?
Oh, do I have to write that? I think the thing is, see, I can't recall everything right now. Whatever you said, I can write down if you want. I have to sit and
Only I
think, to
remember that.
recollect what can be the special cases and again. Right.
Okay, in the next session, can you come up with some page in which it is
Okay,
written?
and okay, my point is you don't require that, for example.
If some objective small type of question came, then
Okay. Okay, the very, very small things are if you add up Bernoullis, you will get binomial. Right? When you add to Poisson also, you will get Poisson like this. When you condition Poisson with Poisson, we will get binomial. What's that special case? We'll get something binomial.
So there's something between this geometric and the binomial, or geometric and Bernoulli.
Okay. Maybe that is why they are called special. Okay, many people will forget. So,
But can you please take up 1 or 2 examples for that next time?
okay, we'll try to take up. Okay, so whatever we discussed today, this will only this is only on weeks 1 and 2 contents. Just try to prepare well with respect to week 1 and 2. Try to submit mock assignment. Try to solve mock assignment. Even though if you submit, just take a look at mock, solve all the mock problems, and if you are unable to solve, take help from your peers or friends. Then you just try to solve the mock, and go through this revision session slides, and on top of it solve few examples. See, solving more and more examples will give intuitions. When a new question is given to you, you will know how to interpret it. You will take less time to interpret the problem. That's where solving more problems will help you. Or else, if you had solved only few problems, whenever a new question appears, you will take more time to interpret the question itself, and that will kill, and then you have to solve and proceed.
Sir, two questions, sir. One is, the solving more problems, you said, right? Is there any specific book do you recommend, or
see, my favorite book I prefer doing is slightly advanced. I right now don't have any. Maybe you can go and see this probability and stat. This was told in the previous session, I guess. Probability and Statistics by Murray R. You can search. Yeah.
Okay.
But if you want slightly difficult problems, this is Statistical Inference by George R. Casella.
George R. Casella. Okay.
Yes, and that is pure advanced, and we don't require right now. Like for quiz point of view, definitely not recommended. But for if you wanna have deeper sense, and if you are really fancied about stats to contents, if you wanna dig deeper into the contents, then definitely this book is a starting point.
Sure. And one another unrelated question: what is the tool you are using, sir, for this presentation?
This is journal.
Journal.
Writing or the application?
No. Whatever you are writing, you are copy pasting and all you are doing.
Okay, this is journal, which is available on Ubuntu.
Ubuntu. Okay. Okay.
And the revision session for 3 and 4 is scheduled on Tuesday from 6 to 8, I guess.
Sir, please share this PDF.
Sir, I also have
Yes, I will share.
one question.
Sir, one request, sir. Sir, there was this mock session of week 1 and week 2, which was held on 16th of October. And sir, the recording of that session has not yet been released, sir. Although the answers, the PDF has been released, but some different approaches were followed for the Kasparov, the chess question and the KFC question. So I just want to refer that.
Okay. Maybe I will ask who has taken the session. Some TA.
Smita ma'am.
No.
Smita
ma'am. The mock session. It was taken by Prakhar. No. The mock. The solution to the mock test of first.
Okay, I understood. Navjot. I will talk to TS, and if the recording is available, that will be uploaded.
I think it was taken by Prakhar.
Okay. Then we will upload.
Yesterday's session was taken by Smita ma'am.
Okay.
Excuse me, sir.
Yes.
Sir, what are the topics for quiz 1 which we have to prepare?
That's what I told till this 2.5 hours, right?
So week 1 and week 2 only, not week 3 and week 4.
That comes on Tuesday.
Okay, sir, actually, I have not been following thoroughly, so I just wanted to know that, what is the syllabus for quiz 1?
So syllabus for quiz 1 is week 1 to 4. and we split our revision sessions into two. In the first revision session, which has happened today, and it is going to end it in 2 or 3 minutes. So,
yeah, got it. Thank you so much.
and the second revision session will be on Tuesday from 6 to 8.
Okay, sir. Thank you.
Okay, then thanks for joining. I am very hungry. I hope many of you are hungry too.
Thank you, sir.
Thank you.
Sorry for
Okay.
delaying your dinner.
Thank you, sir.
That's okay.
Thank you, sir.
Thank you, sir.
Have a
Good night.
great day and all the
Night.
very best for your exam. Bye.
Thank you, sir.
Thank you. It's very informative. Thank you.
Thank you. Thanks. Bye.